Hello everyone, my name is Anurag Kale, and I will be your host. I will be taking you through the basics of DynamoDB. So this particular session is for those people who have not heard of what NoSQL is. They have no idea what DynamoDB is, and what I'll be trying to do is I'll be trying to touch base on the very fundamentals that you need in order to proceed with DynamoDB. So as said earlier, my name is Anurag Kai. I work as a cloud architect at Cybercom Group, and recently also I was recognized as an AWS data hero. You can find more about me on my personal website, from where you will be able to connect with me on various social medias where I'm pretty much active. So what exactly are we going to talk about it? So here is the agenda. So we will first try to understand the nature of DynamoDB, what exactly it is, where does it fall in the categories of SQL, NoSQL, and then various categories of NoSQL. We will also take a glimpse and a look at how DynamoDB functions behind the scene. Then we will also look at how to interact with DynamoDB, and then we will try to understand some of the DynamoDB terms that will serve as the fundamentals of the upcoming different lectures that I have planned for DynamoDB. And then we will look at some demos of using the DynamoDB on the AWS console. Let's get started. So before we proceed any further, let's try to understand what NoSQL means, right? So traditionally, we have been working with databases like MySQL, Postgres, Oracle, or something, and many more. Those are generally categorized as SQL or relational databases. So those were the only databases that were used from, let's say, 1980s until about 2000s. And in 2000s, when the internet boom started, it suddenly became a little painful to manage the relational databases due to various reasons. So people came up with different ways of storing data other than the relational way, which was, you could say, kind of formulated in the 70s. So when we talk about NoSQL, and if you just go to wikipedia.com and try to search what NoSQL is, funnily enough, you'll just find a definition which says that any database that stores data which is not in the traditional table format is called as NoSQL. Well, unfortunately, that's how there is no solid definition of what NoSQL is. But in general, you could say in this industry, there are 4 different categories in which you can divide a NoSQL database. The first category is DocumentDB. Second category is graph databases. Third category is key value pairs or key value database. And then we have white column databases. So when do we use this NoSQL, or you could say one of these 4, right? So document databases are like when you are trying to store complex JSON-like structures in your database, and you are going to query them, try to get complex value, and then pass it in your application and do something with it. A good example of DocumentDB is MongoDB, and a typical use case would be something like, let's say you have an e-commerce website and you're trying to maintain a catalog of all your items, and each catalog has numerous different attributes by which you define them, and these are going to be different as per each of the item. So in those cases, the document databases come in handy. The graph databases are based on graph theory, or the very famous algorithm that you have, like DigiSecra's algorithm. So that is also kind of works on graph. So in graph, what you do is each entity from the from real life is envisioned as a node, and whatever relationships you have between different nodes, they are pointed by the vertices. So when you want to store the value, when you want to have some sort of hierarchical data, when you want to establish relationship between different nodes then you kind of use graph databases. A typical example of the use cases of graph is your recommendation engines, or when you use Facebook. It says that, okay, people you might know, and in people you might know, they will try to suggest you a person who has, let's say, 10 common friends, 15 common friends, 20 common friends. But how exactly do they find that there is a relationship between you and that particular person? Is because they have a kind of connection between one vertex, so one node, which is you, and the one node, which is the other person. And there is some sort of first degree, second degree, or third degree connection. So you find this application in all those social medias typically. And again, recommendation engines, which are used by e-commerce websites, also use graph databases in the background. Then we have this category of key value pairs. So these are the fastest of all the databases. So it's simply as simple as if you are trying to access, let's say, third item in an array. So all you can do is in O of one time, you'll be able to fetch the value if you know the key. So that is basically in very, very rough ways how key value databases work. And then there are white column databases, the typical example. So these are used when, let's say, you want to do a lot of aggregations, and you, instead of storing the data in a row format, you start to store the data in columnar format. So a typical good example of white column is Cassandra. Key values is DynamoDB. For graphs, there are multiple examples. I'm blanked out. Okay, a typical example for graph database would be Neptune. Key values database would be DynamoDB. That is what we are going to talk about. Then for white columns, that is Cassandra, and as I said earlier, for document DB is MongoDB and the likes. So where does DynamoDB fit into this in this category? It is primarily a key value database, which also can do some functions of a document DB, but generally it is categorized as a key value data store, but it can do much more than what a typical key value database does. So what exactly is DynamoDB? So like we touched based upon a few moments ago, it's a key value plus document kind of database. The distinction is it is fully managed by AWS. So when we move to the console, you will see the stark difference of how the database operates. It is totally serverless. That means you don't need to tell AWS that you want 4 servers, 60 gigs of RAM, 300 GBs of storage. Beforehand, your database can scale as your application scales, and you will only pay for the capacity that you are consuming. It is built for scale. So given you design the database properly, you can expect less than 10 millisecond response for your request from DynamoDB at any scale. When I say any scale, you will get the same response if your database is, let's say, 1 gigabytes, or if you are going into hundreds of terabytes, or sometimes even it says that some people claim that it is the same in petabytes. It is one of the, you could say, early cloud native kind of databases, which has been functional for quite some time. So let's take a quick look at the architecture, and then we will kind of switch to the console and try to take a look at how DynamoDB works. So what are the key components? Like I said, these components are something which you will never come across. You will not touch them. You will not be interacting with them directly. They are abstracted away from you because it is a serverless database. But then it is very imperative to understand how exactly DynamoDB works. So I'll be introducing some of these components to you so that you understand the implications of this architecture when you're doing your data modeling on top of DynamoDB. So there are you could say 4 main components: the request router, there are compute nodes, there is an authentication system, and then there is something called as auto admin, which does all the tasks for you, that all the DBA kind of tasks for you, which kind of makes DynamoDB as a less ops or no ops kind of no ops database. So how does it work? Let's say you want to create a database in DynamoDB in one of my many AWS regions. What AWS does is it has, of course, there is a network, but the request routers that you see in green here, and the storage nodes that you see a component as red. So all of these request routers and storage nodes are shared, or they are deployed in all the availability zones which are available in the region. So in a typical good region, in a typical region like Mumbai, let's say, for example, you have 3 availability zones. So when you have 3 availability zones, you'll have request routers which are spanning across the 3 different availability zones. And there are storage nodes as well, which are which are spanning across the availability zones. So what happens is, let's say you make a network request and you send a query or a scan on your DynamoDB table. So in this case, let's assume it is a query. So we will come to the definitions of that later. But when you send a request to when you send a request to DynamoDB's endpoint, it is basically routed to the request router. The request router, what it will do is it will read the partition key or the primary key of the request. It will hash the value of that particular column, and depending on the hashing value, it is going to point the request to the appropriate storage node. So whenever you write data, the primary key plays a very important role. The hash of this primary key will determine which node it will go and sit into, and DynamoDB will internally replicate that particular data in at least 2 more nodes. So by default, you have a high availability taken care of for you by Amazon. So what if request router goes down? Then in this case, request routers are also replicated and available across availability zone. So there is a very less chance that you make a request and it will fail. So let's move on and let's jump on to the management console and take a look at how exactly AWS how does DynamoDB look like. So in AWS Management Console, I have logged in. I have chosen my appropriate let's say region. Now you go in all services and you will find DynamoDB under databases. Again, no, it's a no-brainer. So in databases, you'll find that there is DynamoDB. So if I click on DynamoDB, you will find a page. It says that what exactly DynamoDB is. It's telling me that it's a fast and flexible NoSQL database for all the application that needs consistent single-digit millisecond latency at any scale. So that is something that we talked about. Now let's do one thing. We will try to create a table into this, and we will come back to the PPTs, and I'll introduce some more terms to you. So the very first distinction that you will see is it says here that you need to create a table. So it is not asking you to create any servers. It is not asking you to create any users, which is typical of a relational database service. So when I say create server, it redirects me to a page where it asks me that, okay, please give me a table name. Please tell me what your primary key is. And there are certain more components to this. So the key takeaway or the reason that I brought you over to the console is to let the concept of serverless sink in. So here I have not told DynamoDB that I want certain sort of server, I need certain amount of CPUs, I need certain amount of RAM and all that stuff. So it directly tells me that come on in here and create a table. So we will get back to this particular you could say section in a few minutes. Let's for now let's go back to our slides. So how do I work with DynamoDB, right? So there are 3 ways with this. There's another way which I've not included, which is called as PartyQL, but these are the 3 primary ways that you interact with them. So the one is console, the way I did. You can go to the AWS UI, look at it, and do stuff on top of it. You can also interact with DynamoDB by using the CLI, and for programmatic access. So when you want to interact with DynamoDB from your programs, from your applications, then you use the SDK for the appropriate language for DynamoDB. So in general, DynamoDB SDKs are available for most you could say famous languages like Python, Java, .NET, C#, and all that stuff. So before we go ahead, let's try to get acquainted with some basic DDB terms or DynamoDB terms. So as we saw in the small glimpse when we looked at the console, there is nothing as database or a server in DDB. So the very fundamental unit of operation in you could say in DynamoDB is a table. So this the green box that you see, which is kind of representing some sort of a schema at this moment, is a DynamoDB table. You will give on the screen when it asks me to give me a name, it is basically giving a name to this particular data structure and calling it as a table. Now, in a table, what we have is a combination of key values. So the key in this case is a primary key, and the values is a set of combination of attributes. So in primary key, what we have is we have two kinds of primary keys. First primary key is the simple primary key, in which all you have is a partition key, and we have then a composite primary key, which we will look at in a moment. So a simple primary key, in a simple primary key, all you will have is a partition key, and on the right you can have as many different attributes as you want for that particular item. Then there is what we call as composite primary key. So the composite primary key is a combination of two different columns. If you have to say it that way in the relational world, one is the partition key and one is the sort key. So what function do these two different things perform, right? So the partition key is the key. If we go back to this particular diagram, the request router is always going to look at just the partition key to find where exactly is your data residing in these three availability zones. So for when you are making a query to DynamoDB, the least amount of data that you need to provide it is a partition key. So from the table, it will take the partition key, create a hash value, and depending on the hash value which is stored in the request router, it will point you to the right storage nodes, and then you can do the rest of the stuff on top of it. So what function does sort key perform? So once you are in the request router, and from request router you have gone to the storage node, so what happens is now you have a big you could say chunk of your data, or what you have is in SQL terms, you have a partition to deal with. Now if you want to do any filtering in this partition, then you use the partition key. Now be aware, and this is something which is new and it's very difficult for people to comprehend, that the filtering that you can do in DynamoDB can only be done on the sort key that you have defined. So you cannot go into the table. For example, let's get back to the example, and let's say you cannot write an equivalent query of select something from table where primary key is order ID 001 and selling price is 20. You cannot do that. In DynamoDB, you can do the filtering only on the sort key. So in sort key, you can say that, okay, where my sort key is like 156 is equal to item hash 156. Or you can also say that, okay, if this was just numeric value, you could say that the sort key is less than, let's say 100, for example, or greater than or equal to 100, less than or equal to 100, or between 100 and 150. So you can do filtering only on the sort key. You cannot do the filterings on the other attributes that you have. This is by design, and this is how DynamoDB works, and this is what helps DynamoDB to operate at bigger scales without having any distortion in your response value or the response speed. So this is the design, and this is very difficult for people coming from SQL background or who know SQL to comprehend. So it is very imperative, it is very important that you choose the right partition key and the right sort key in order for your DynamoDB to work well for you. So how are we going to how to choose the primary key and sort key? We have a dedicated video for that, which I'm calling as data modeling on DynamoDB. So you can look at this when you're familiar with the concepts of DynamoDB. So now that we have understood what a table is, what a simple primary key or a partition key is, and then what we have looked at is a partition key and sort key, let's look at what is an equivalent of a row, right? So a combination of primary key and sort key and a collection of attributes is called as an item. So if you carefully observe here that in order 001, for example, in item 156 and 157, you will find that there is a mismatch of the number of attributes that you have. And if you carefully observe between 156 and 158, there is certain terms which are not at all available in one of the above items. So this is the power of NoSQL. What you can do is you can have very different set of attributes for each row, which is called as an item in NoSQL. So this way, you can work in your application in what is termed as a schemaless database, because as long as you have well-defined partition key and sort key, your attribute and attribute values generally do not matter, or they do matter, of course, but you can have as many different you could say combinations of those as possible. For example, for again 001 order ID, there is a different sort key for profile, and profile has name, address, and customer since, which is not at all a part of any of the other items here. So this I've already touched based on. So for each in the item, when you remove the partition key, and whatever remains are attribute and attribute values. So these kind of are stored in the JSON format. Again, key value pairs within key value pairs. So you can have multiple sections. You can have multiple different values for the attributes. Now let's get back to the console and try to create our very first table. So we will use the same example that we are seeing here. So here, let's say what I was trying to do is I was trying to create a simple, let's say, store database where it is trying to make a grocery store kind of stuff. So let's say I went back to the console and I'm saying here that, okay, the name of my table is grocery store, right? Now in the grocery store table, what it says is you need to, this is a compulsory, you need to define a primary key and at least the partition key. Adding a sort key is optional, but again, if you don't add a sort key, you will be only able to use DynamoDB for simple lookup kind of use cases. So in our case, let's say I want to also have a partition key and a sort key, and I will just click this particular box and it will open up. So going back to the examples, you have primary key, PK, and the PK is a combination of primary key is a combination of partition key and sort key. So what generally people do is, in order to maximize the different patterns that they can have query with, they always give a generic name as PK for partition key, and for sort key they give the name as SK. Why we are doing that, you will understand that in our next video. But for now, just you could say, just consider that a fairy has came along and just told us that, okay, the partition key is named as PK and the sort key is named as SK. And then what you can do is here you can define the data type of this particular partition key or sort key. So I'm going to stick with a string for now because that's what I'm going to use. And now when you scroll down, you'll see that there are different table settings. So here it says that if you see, it says use default settings. So when you use default settings, there are no secondary indexes. The capacity is provisioned at 5 reads and 5 writes. The basic alarms are now with 80% threshold, and encryption at rest is enabled. So what are these? So these are a little bit of advanced terms which I'll try to introduce in a few moments. But if I uncheck that, what I can do is I can create something called as an secondary index. I can tell exactly my read and write capacity mode, right? So in the read and write capacity mode, you will see that there are two modes. First mode is the provision mode, and second one is on demand mode, right? So how exactly this works? So till now we have talked about that there is no database, there is no VCP, there is no telling of how much RAM, how much storage, and how much you could say vCPUs that I need. Then how exactly the billing will work, right? So that's a very big question. So the billing actually works. There are two different parts in which the billing works. Let's say you are billed for the amount of storage that you are doing in DynamoDB. So let's say your database size for today is, for this entire month of July, was 10 GB. Then you will be charged for whatever value of per GB value for DynamoDB into 10. So that is the fixed price for the storage. But let's say you have done certain number of reads and certain number of writes on that particular table. So those will be added on top of your storage cost. So the combination of bill, the way DynamoDB will make you a bill, is combination of your read and write plus your storage amount. Now, to understand the billing requirement, right? So there is a very nice, you could say, table which you can find in DynamoDB pricing page. So go to the DynamoDB pricing page, and you will find that there are two modes here. So there is a pricing for on-demand capacity mode, and there is pricing for provision capacity mode. Now, when to use these modes? So let's say on-demand mode, as the name says, that it will the DynamoDB's auto engine internally, what it will try to do is it will try to increase and decrease the capacity of your application depending on how much request or writes comes to it. So you don't need to forecast your capacity requirements and let DynamoDB scale up or scale down as per your requirement, as per the number of requests. Now, when is this helpful? Let's say you're a very new application, you're a very new startup, and you don't know how exactly it is going to be received by the market. Then you can start with on-demand capacity mode, run your application for 15 days or 30 days, try to get a feeling of the number of read write requests that is happening every month or every day, every minute, and all that stuff. And then when you have a good number of looking at what we have, then you can switch to provision capacity mode. Because DynamoDB's on-demand capacity mode gives you a little more flexibility, the amount or the money that you pay when you're in on-demand mode is slightly more than the provision capacity mode. So what provision capacity mode means is basically you are telling DynamoDB that, okay, these are the number of read and write requests that I'm expecting this month, and this is how much I'm willing to pay. Please remain within this particular capacity. So with this particular thing, you will have a very, you could say, fixed kind of rate of running your database, running your DynamoDB database. So now what you can do is, if you click on-demand capacity mode and say learn more, it will take you to another page. So again, it's a very nicely described page, and you should definitely go through it and try to read it. But in a short, what we will try to do is we will see how read and write request is going to affect the value affect the bill, right? So what basically is, now the prices are as per region. So choose the region that you are in, and the prices will differ a little bit per region. So here it says that the charge for write request unit is 1.3428 per million write request unit. Now, what is the write request unit, or WRU, and or it is something called as WCU and RCU? We will be looking at in the next session, because these are fairly, you could say, advanced topics to basically calculate. And if you read, then you need to pay 0.269 per million read request units. So that is how you are charged. You are also charged for the data storage. So for this particular, for the data storage, you say that first 25 GB per month is free, but for each GB of data that you store henceforth, you are paying 0.269 GB per month. Now, what you also pay for, when I mentioned earlier, you need to pay for read and write requests. You also need to pay for data storage. What you also need to pay for is if you are using the kind of backup and restore strategy. So if you are using continuous backup, or which is called as point in time recovery. So basically, if you want the capability of DynamoDB saying that, okay, hey, I messed up, can you go back 15 minutes and restore the database how it was 15 minutes ago? So if you want that capacity, then you need to pay more for that. And for on-demand backup is basically you will have you will manually go in and tell that, okay, it's time to take a backup, and the charge that you need to pay for that. And when you are trying to restore a database, then also you need to pay certain amount. You also pay for more other features, like if you are using global tables, if you are exporting data to S3, if you are using Dynamo Accelerator or DynamoDB streams, etc. So these things are fairly advanced topics. So we'll perhaps get back to them in some other section. So also you need to pay, you could say, for data transfer. So for data coming in to the DynamoDB, you don't need to pay any value. But let's say you are querying the database and taking the data out, then first 1 GB of data that is taken out from the storage is free, but for the next 999.999 TB, you will have to pay 0.09 GB per month. So how the billing will work out? So the billing will be a combination of how many reads and writes you make, how much data you store, what kind of backup and restore strategy that you're using. If you're using global tables, then are you using any advanced features of DynamoDB, like change data capture, exporting to S3, and then the amount of data that you are transferring out of DynamoDB. So a combination of all of this is going to basically give you a total bill. But there is a free tier which kind of helps you get understanding of this, and you can work with this without any issues. So you'll have first 25 GBs of storage free, 2.5 million stream requests from DynamoDB is free, and 1 GB data transfer out is also free. So here is a nice example that it gives out for basic example, right? So let's say so you have these many reads. So it's like I think 3.5 million reads or something. So if you have 3.5 million writes and 3.5 millions of reads, your monthly bill will be $4.4, and your total read request will be $0.89. So this is for you could say for this amount of throughput, this is pretty cheap. But on top of this, you will also have to add the features, the billing that you are incurring from other features that you are using out of DynamoDB. So this was for on-demand capacity mode. There is similar kind of setup for you could say provision mode, and here it says the RCUs and WCUs, and this is the cost of the RCUs and WCUs. Again, this is something that we will take up in another lecture to understand. Now, getting back to the console, let's say I'm not using default settings. Then I can tell DynamoDB that, okay, I'm okay with provision mode or on-demand mode. Let's say for now, for the sake of the demo, I'll say it's provision and I don't want to incur any charges. Then for the provision mode, for your first five, you have 5 RCUs and 5 write and read capacity units for free. So roughly a read capacity unit is like you can write up to 4 KB of item into database, and you can do 5 writes per second. And for read, you can read 1 KB of data per second, and you can read up to 5 different items. And then you can have some sort of auto scaling capacities, and you can define the encryption for your database. You can add tags if you want. So these topics are fairly advanced, and we will look at them in the next upcoming lectures. And then you just hit on create. Now it will take just a little moment, and then it will create a table for us which basically is nothing but your database. So, okay, here now our table is ready. This is called as grocery store. So that's it. This is your database. So if you look at overview, you can do certain things out of it. Now, if I choose on items, so this is where you will start to get, or you can start creating and inputting data and then trying to retrieve the data. So let's do one thing. Let's try to write or create some database out of it. Let's write a value into it. So let's take this example and let's say we will use the same example here. So my PK is order ID 001. So let's add that. So here is my value. It's order ID 001. And my sort key is item hash 156. So item hash 156. So in case you're wondering why I'm adding hash and then adding numbers, so there is certain, you could say, there is certain logic to it. So which we will look into it more. And now what you can do is, if you want to add more attributes, you can just say insert, and let's say I want to add a string kind of attribute, right? So it says now you are getting a field and a value, which is string. So what we can do is, let's say we add manufacturer. So the name of the item is manufacturer, and the value is, let's say, barley, for example, right? Now, let's say if I want to insert another string and I want to say price. Now, I don't want, now the price is not a string, it has to be a number. So let me redo that, insert, and I want to add a number. And I will say it's price, and let's say 10. And then I'll add, let's say, another attribute, and it is, let's say, binary, and we will say is in stock, for example, and the value is, let's say, true. And I can click on save. So when I clicked on save, it actually created this row for us. Now this row is referred to as an attribute. Let's try to create another item so that you understand the power of Power BI, and now, sorry, for of DynamoDB. So let's add the last value. So again, we are going to keep order ID as 001, but the sort key right now is profile. So let's say profile number 10. And now I want to insert the other attributes. Let's say here it is. Oops. Okay, no worries. So let's say I want to add name, address, and customer since. So what I can do is I'll go back to the console and I'll add the attribute name, give it some value, and we will add another string, and it will say address, and I'm going to say, let's say, Pune MH, and I can then again insert, and I'm going to add another string, and I'll say just say date since customer, for example, and I'll say 0101 2018, and then click on save. So here you see it is the same table, grocery store, and we have the two different values. Now here's a mistake I did. So the order ID has to be, because upper caps and lower caps have different values, the hashes are going to be different. So this perhaps will go to a separate partition. So be aware of that. But here you can see in the same grocery store example, we have two different items which have different, you could say, attributes or different columns altogether. So likewise, you can add as many as you want. And if you want to, let's say, assume that this particular table had hundreds of values and you wanted to find one particular value. So instead of scan, never use scan. Now, what is a scan? We will cover it in the advanced topics, but we always use query. So when you say query and you say that I want to find it on a grocery store, what you see here is it says that, okay, so it by default says that give me at least partition key and sort. These are the values only by which you can filter. Let's try to give it another search. Just say query, and I'll just copy the value. Let's click on this, and I'll just copy the value so that I don't do any. I know what I did a mistake. So it must be order ID hash. And then if I search it, you will find that you are able to look into this particular item. So without SK, it was able to point to me that, but if you wanted, if you go back to the example on screen, you will see that these all attributes, these all items had the same partition key. So if I had all these values in the table, then it would have brought me all of these items. Now within that item, if I was only interested in, let's say, item hash 156, then what I could do is I could go here and tell into the string that I want to look at item hash 156 and item. So the value, you need to be specific with the values, and if you still get here. Now you might say that you mentioned that you cannot do filtering on top of the other attributes, but you see an add filter value here. Now you can do filtering by using some other attributes only after you have isolated that particular section of data with the partition key or sort key. So what you cannot do is you cannot have a third attribute which is not a part of primary key and sort key serve as the only filtering you could say capacity, or only filtering value. So what if you want to do that in certain cases, which is not advisable, what you should use instead is you should use what we call it as a scan. So now be aware that when you do query, what you are doing is, because of the DynamoDB architecture, if I go back to go back a second, when you make a query, you are first from the request router, you have been isolated to just one node in which you have your data. But if you do query, so the query only fetches data from that particular node. But if you say scan, it will not go through the request router, but it will rather it will go in each of the nodes one by one to find that value for you. So if you have a big table, that means that you will get a huge bill at the end of the month if you are using scan. So never use scan until and unless it is very necessary. So for example, in our case, because our table only has a couple of a couple of items, then it's safe for me to do that. But please do not do this in production, and do not do this for big numbers when you have big numbers in your tables. So this is how you can basically overall create a small table, and you can now have multiple values inside it. You can have tons and tons of data with this. Now, this is not the only way you interact with DynamoDB. You can do all of these actions, basically a scan or a query from the SDKs for your appropriate language, and do all of this programmatically. So yeah, without that, the database would have been of no use. Let's get back to the slides. So now we have seen what DynamoDB, how it looks like. Let's look at a small topic. Let's touch base on the small topic, which is very important. So if you remember, I mentioned that all you can do is you can do your filtering using partition key and sort key. And once you have isolated the partition, you can then add more attributes and make next further sorting. But that kind of limits your capabilities to do, you could say, that kind of limits your capabilities of what can be done using DynamoDB. So for that, there are two secondary indexes that you can create on top of your DynamoDB. So the first one is called as a local secondary index, and the second is a global secondary index. So a local secondary index, in local secondary index, what you can do is you can, on your particular table, create a second sort key. So let's say if you have created a table in which you have an attribute which is kind of present in all of the items, and you want to do a filtering by that particular attribute, then you can create an LSI or a local secondary index. But be aware that LSI can only be defined when you are creating a table. It cannot be created once the table has been created. The LSI will share capacity of read and write units with its mother table. So basically, whatever you have provisioned will have to, the LSI will use out of that. But there is a hard limit that an LSI per partition cannot exceed 10 GBs. So generally, it's suggested that avoid using LSI as much as you can. Then there is what we have. We have something called as a GSI, or a global secondary index. So what you can do in global secondary index is you can define a different set of partition key and sort key for your DynamoDB table. So in the background, what happens is DynamoDB replicates your entire data from the primary table and creates a copy of your data, and changes the partition key and sort key for that. So in theory, or in practice, although you are interacting with one table, in the background, this is a whole different data structure, or a whole different table that you're going to deal with. But what you can do is you can create projections. So what a projection is, you're basically, when you create a global secondary index, you have to specify that, okay, I'm interested in these two columns as partition key and sort key, and these are the other attributes that I want to bring over from the mother table to the global secondary index. We will look at some of these examples in the advanced topics, but this is something that you need to know, so that you understand the next session of doing data modeling on top of DynamoDB. So this was a very brief introduction to DynamoDB. Thank you very much for listening to me. If you have any questions, you have my social profiles. You can reach out to me if you have any questions. Thank you, and have a great